What is the kinetic molecular interpretation of solids? The kinetic molecular interpretation of solids refers to microscopic model that explains behavior of solids based on movement and interactions of their constituent particles. In this model, particles are arranged in a fixed three-dimensional lattice structure and vibrate around their equilibrium positions. What are the types of solids based on kinetic molecular interpretation? Based on kinetic molecular interpretation, there are three main types of solids. Amorphous solids, these lack a regular long-range order in their molecular arrangement. Examples include glass and amorphous polymers. Second is crystalline solids. These have a highly ordered repeating pattern of particles in three-dimensional lattice. Examples include salt crystals and diamonds. And the third is liquid crystals. These have properties of both liquids and solids with an ordered arrangement of particles in one or more dimensions. What are the properties of crystalline solids? Crystalline solids possess several distinctive properties. Definite geometric shape. Crystals have well-defined regular shapes with sharp edges and smooth faces due to their ordered arrangement of particles. Second is anisotropy. Crystals exhibit different physical properties. Example, refractive index, thermal conductivity when measured along different crystallographic directions. Third is melting point. Crystalline solids have characteristic melting point at which they transform from solid to liquid state. Fourth is cleavage and fracture. Crystals can break along specific planes with smooth surfaces or irregularly due to the lattice structure. What are the types of crystalline solids? Crystalline solids are categorized into four main types based on the nature of their bonding and atomic or molecular arrangement. First is ionic solids composed of positively and negatively charged ions held together by electrostatic forces. Examples include sodium chloride and potassium nitrate. Second is covalent network solids, formed by an extensive network of covalent bonds between atoms. Examples include diamond and quartz. Third is metallic solids, consist of metal cations held together by a sea of delocalized electrons. Metals like iron and copper are examples of metallic solids. Fourth is molecular solids composed of discrete molecules held together by weak forces such as van der Waals or hydrogen bonds. Examples include I and solid carbon dioxide. What is a crystal lattice? A crystal lattice is a three-dimensional repeating arrangement of atoms, ions, or molecules in crystalline solid. It represents the fundamental unit cell that repeats throughout the entire crystal structure. The lattice points are positions occupied by the constituent particles, and the lattice vectors define the periodicity and orientation of unit cell. How does the arrangement of particles in amorphous solids differ from crystalline solids? In an amorphous solid, arrangement of particles lacks long-range order and does not exhibit repeating pattern. The particles are more randomly arranged, leading to disordered and irregular structure. On the other hand, in crystalline solid, arrangement is highly ordered and the particles repeat in three-dimensional lattice pattern. Why do crystalline solids have defined melting point? Crystalline solids have defined melting point because the ordered lattice structure breaks down at specific temperature, causing solid to transition into liquid. The melting point is characteristic property of substance and remains constant under a given pressure.